The F-22 Raptor has never lost a single air-to-air engagement, maintaining a perfect 108-to-0 kill ratio in combat exercises. The MiG-21 became the most produced supersonic fighter in history, with over 11,000 built. The F-15 Eagle achieved 104 victories with 0 combat losses across 5 decades of service. These aren't just statistics, they're the legacy of the most dominant fighter aircraft ever created. From Cold War legends to modern stealth monsters, these 10 warbirds redefined aerial combat and shaped the future of military aviation.
F-4 Phantom II, the Double Ugly Legend.
A fighter so ugly it earned the nickname Double Ugly became the most produced American supersonic military aircraft in history, with 5,195 built between 1958 and 1981. The McDonnell Douglas F-4 Phantom II proved that raw power could overcome questionable aesthetics. This twin-engine beast could carry over 18,000 pounds of weapons on 9 external hardpoints, while reaching speeds exceeding Mach 2.2. Its cavernous air intakes and drooped nose gave it an ungainly appearance, but the Phantom's performance spoke louder than its looks. The aircraft set 15 world records for in-flight performance, including absolute speed and altitude records. The F-4's combat debut came during the Vietnam War, where it served as the principal air superiority fighter for all 3 U.S. services. Every American pilot who became an ace during Vietnam, 5 total, achieved their status flying Phantoms. The aircraft's versatility allowed it to excel in air-to-air combat, ground attack, and reconnaissance missions. What made the Phantom revolutionary was its multi-role capability decades before the term became common. Initially designed without an internal cannon, later variants incorporated the M61 Vulcan rotary cannon after Vietnam combat experience revealed the need for close-range firepower. The F-4's adaptability kept it relevant across multiple conflicts and with numerous allied nations. Despite its unconventional appearance, the Phantom became a signature aircraft of the Cold War, serving with 11 countries besides the United States. Its combination of speed, payload capacity, and technological advancement established the template for modern multi-role fighters. MiG-21, the People's Fighter. One aircraft has been flown by approximately 60 countries across 4 continents and still serves many nations 7 decades after its maiden flight. The Mikoyan-Gurevich MiG-21 Fishbed became the most produced supersonic jet aircraft in aviation history, proving that simple, effective design trumps complexity. The MiG-21's pencil-shaped fuselage and delta wing configuration created an aircraft that was both affordable and deadly. Its nickname Balalaika came from its planform resembling the Russian stringed instrument, while Vietnamese pilots called it On Bak, or Silver Swallow. This small fighter could reach Mach 2.05 and climb at 225 meters per second. What made the MiG-21 extraordinary was its operational simplicity. Unlike complex Western fighters requiring extensive maintenance, the MiG-21 was designed for rapid turnaround and minimal ground support. Its single Tumansky engine and straightforward systems allowed less developed nations to operate sophisticated supersonic fighters. The aircraft's combat record spans dozens of conflicts worldwide. During the Vietnam War, North Vietnamese MiG-21s proved formidable opponents against American F-4 Phantoms and F-105 Thunder Chiefs. The fighter's small size and high speed made it difficult to detect and engage, while its heat-seeking missiles proved effective in close combat. The MiG-21's longevity stems from continuous upgrades and modifications. Modern variants like the MiG-2193 incorporate advanced avionics and weapon systems while maintaining the original airframe's proven characteristics. This evolutionary approach kept the Fishbed relevant across multiple generations of aerial warfare. F/A-18 Hornet, the carrier warrior. The first aircraft designed from the ground up to be both a fighter and attack platform, the McDonnell Douglas F/A-18 Hornet revolutionized naval aviation by combining air-to-air and air-to-ground capabilities in a single airframe. This twin-engine marvel proved that versatility didn't require compromise. Entering service in 1983, the Hornet replaced both the F-4 Phantom and A-7 Corsair in U.S. Navy and Marine Corps service. Its unique design featured canted vertical stabilizers, leading-edge extensions, and a digital fly-by-wire control system that provided exceptional maneuverability at high angles of attack. The aircraft could remain controllable in flight regimes that would stall conventional fighters. The Hornet's combat debut during Operation Desert Storm demonstrated its revolutionary dual-role capability. Hornets shot down enemy fighters and bombed ground targets within the same mission, proving the concept of true multi-role operations. Aircraft that took direct hits from surface-to-air missiles successfully recovered, were quickly repaired, and flew again the next day, cementing the Hornet's reputation for survivability. Powered by twin General Electric F404 engines producing 17,750 pounds of thrust each with afterburner, the Hornet could reach supersonic speeds while carrying substantial weapons loads. Its 410 square-foot wing area and advanced flight controls provided the agility needed for both air combat and precision ground attack missions. The FA-18's carrier-based design requirements created an aircraft optimized for harsh operating conditions. Its robust landing gear, corrosion-resistant materials and folding wings made it ideal for naval operations, while its reliability and maintainability kept operational costs manageable throughout its service life.
Dassault Rafale, the French omni-role master.
While other nations built specialized fighters, France created an aircraft capable of performing every mission from air superiority to nuclear deterrence in a single sortie. The Dassault Rafale represents the pinnacle of European fighter design, combining advanced technology with operational flexibility. The Rafale's distinctive canard delta configuration provides exceptional maneuverability, allowing the aircraft to withstand forces from -3.6 G to +9 G in normal operations. Its aerodynamically unstable design requires digital fly-by-wire controls to maintain stability, but this instability provides the agility needed for modern air combat. The aircraft can fly as slowly as 15 knots during training missions while maintaining control. What really sets the Rafale apart is its domestically developed technology. The RBE-2 active electronically scanned array radar, Optronique Secteur frontal infrared search and track sensor, and direct voice input systems were all created specifically for the Rafale program. This technological independence allows France to upgrade and modify the aircraft without foreign restrictions. The Rafale's omni-role capability means it can switch between air-to-air and air-to-ground missions during flight without returning to base. Its 14 hardpoints can carry up to 21,000 pounds of weapons, including Meteor air-to-air missiles, Storm Shadow cruise missiles, and ASMP nuclear weapons. This flexibility makes each Rafale equivalent to multiple specialized aircraft. The aircraft's naval variant, the Rafale M, demonstrates French engineering excellence. Despite being carrier-capable, it retains 95% commonality with land-based versions and cannot fold its wings, a design decision enabled by France's nuclear-powered Charles de Gaulle carrier. This commonality reduces training and maintenance costs while maximizing operational flexibility.
Eurofighter Typhoon, the European collaboration.
4 European nations overcame decades of rivalry to create a fighter that could challenge American air superiority, resulting in the Eurofighter Typhoon, a twin-engine marvel that combines the best of British, German, Italian, and Spanish aerospace technology. This multinational collaboration produced one of the world's most capable air superiority fighters. The Typhoon's development began in 1983 as the Future European Fighter Aircraft Program, originally including France before disagreements over design authority, led to France's withdrawal to develop the Rafale independently. The remaining partners created a consortium of Airbus, BAE Systems, and Leonardo that continues to manage the program today. Powered by 2 engines producing 150,000 horsepower combined, the Typhoon can reach Mach 2.35 and climb to 11,000 meters in just 2 minutes. This exceptional performance makes it ideal for quick reaction alert missions, intercepting intruders before they can penetrate national airspace. The aircraft's canard delta configuration provides the agility needed for modern air combat scenarios. The Typhoon's combat record includes operations in Libya, where Royal Air Force aircraft participated in airstrikes destroying tanks in 2011 as their combat debut. The aircraft's precision strike capability, combined with its air superiority mission, demonstrates the multi-role flexibility that defines modern fighter design. With over 850,000 flight hours accumulated and 680 aircraft ordered by 9 nations, the Typhoon forms the backbone of European air defense. Export customers including Saudi Arabia, Oman, Qatar, Kuwait, and Austria demonstrate the aircraft's international appeal and operational effectiveness across diverse operating environments.
F-15 Eagle, the undefeated champion.
No fighter aircraft in history has achieved what the McDonnell Douglas F-15 Eagle accomplished. 104 air-to-air victories with 0 combat losses over 5 decades of service. This twin-engine air superiority fighter established a combat record that remains unmatched in modern aviation. Designed in response to the Soviet MiG-25 threat, the F-15 first flew in 1972 and entered service in 1976. Its massive twin Pratt and Whitney engines and advanced radar gave it capabilities that overwhelmed contemporary opponents. The aircraft's not-a-pound for air-to-ground design philosophy created a pure air superiority fighter optimized for one mission, controlling the skies. The F-15's combat debut came with the Israeli Air Force in 1979, where it quickly established its dominance. During the 1982 Lebanon War, Israeli F-15s achieved multiple victories against Syrian aircraft without suffering a single loss. This pattern continued in U.S. service during the Gulf War, where F-15Cs accounted for 34 of 37 Air Force air-to-air kills. What makes the F-15 extraordinary is its longevity. 50 years after its first flight, the aircraft remains in production with the F-15X variant. This latest version incorporates modern avionics, fly-by-wire controls, and advanced electronic warfare systems while maintaining the proven airframe that has never been defeated in air combat. The F-15's weapons capacity is legendary. The F-15EX can carry up to 22 air-to-air missiles, more than any other fighter in production. Combined with its APG-82 AESA radar and advanced electronic warfare suite, the modern Eagle remains a formidable opponent for any adversary aircraft.
Sukhoi Su-27, the Soviet Sky Dancer.
Soviet engineers created a fighter so agile it could perform maneuvers that, honestly, seemed to defy physics, challenging Western assumptions about aircraft design, and establishing the Sukhoi Su-27 flanker as arguably the finest air superiority platform of the 20th century. This massive twin-engine fighter combined size with grace in ways that really redefined aerial combat. Development began in 1969 as a direct response to the American F-15 Eagle, with chief designer Mikhail Simonov gradually refining the design into a masterpiece of aerodynamic engineering. The Su-27's distinctive shape, with its long fuselage, widely spaced engines, and graceful curves, created an aircraft that was both beautiful and deadly. The Su-27's performance specifications read like fantasy: Mach 2.35 maximum speed, 18,500-meter service ceiling, and a 3,530-kilometer range. More importantly, its thrust-to-weight ratio of 1.07, with partial fuel load, gave it acceleration and climb performance that matched or exceeded any Western fighter. The aircraft could pull plus 9G maneuvers while maintaining control at extreme angles of attack. What truly set the Su-27 apart was its maneuverability. The aircraft could perform the Cobra maneuver, pulling its nose up to 90 degrees or more while maintaining forward flight, demonstrating control authority that Western fighters just couldn't match. This super maneuverability came from its relaxed stability design and powerful flight control system. The Su-27's combat record, while limited, proved its effectiveness. Ethiopian Su-27s shot down 5 Eritrean MiG-29s during the Eritrean-Ethiopian War, demonstrating the flanker's superiority even over its intended partner aircraft. The Su-27's influence extends through its numerous variants, including the Su-30, Su-33, Su-34, and Su-35, each optimizing the basic design for specific missions.
F-22 Raptor, the Invisible Predator.
The F-22 Raptor, known as the Invisible Predator, achieved something truly unprecedented in modern aviation: a perfect combat record of 108 victories and 0 losses during realistic combat exercises. The Lockheed Martin F-22 Raptor stands as the absolute pinnacle of American aerospace technology, blending stealth, supercruise, and maneuverability in ways that, honestly, just redefined what air superiority means. The F-22's development kicked off in 1981 as the Advanced Tactical Fighter Program, with Lockheed Martin's design coming out on top in 1991. Its revolutionary mix of radar-absorbing materials, thrust vectoring, and integrated avionics gave it capabilities that, just a few decades earlier, would have seemed impossible. Stealth technology makes the F-22 almost invisible to enemy radar, allowing it to engage targets without ever being detected. And when you pair that with its ability to super cruise at Mach 1.5 without using afterburners, The Raptor can show up anywhere in the battle space, totally without warning. Its thrust vectoring engines give it maneuverability that outclasses even the most agile conventional fighters out there. But what really sets the F-22 apart is its combat systems integration. The radar, weapons control, and electronic warfare systems all work together as one seamless unit, providing pilots with situational awareness that gives them a huge advantage. During Exercise Northern Edge in 2006, F-22S racked up a 108-0 kill ratio against top F-15, F-16, and F-18 adversaries, all while maintaining a 97% mission capability rate. Production limitations make the F-22 pretty exclusive. Only 187 operational aircraft were built before the program wrapped up in 2012. This scarcity, along with export restrictions to protect its advanced tech, ensures the Raptor stays America's ultimate air superiority weapon. The aircraft's capabilities are so advanced it's expected to remain the U.S. Air Force's premier fighter well into the 2040s.
F-16, Fighting Falcon, the Global Guardian.
The F-16 Fighting Falcon, often called the Global Guardian, is the one fighter aircraft that serves with more air forces around the world than any other, proving that, sometimes exceptional design really does transcend national boundaries. The general dynamics. F-16. Fighting Falcon became the most widely used fighter jet on the planet, with over 4,600 built and flown by more than 25 nations. The F-16's revolutionary design brought fly-by-wire flight controls to production fighters, which allowed an aerodynamically unstable aircraft to pull off some pretty incredible maneuvers. Its side-mounted control stick and reclined pilot seat helped reduce G-force effects, letting pilots handle sustained high G-turns that would knock out pilots in more conventional jets. The bubble canopy offered 360-degree visibility that was just unmatched by any other fighter at the time. What really made the F-16 special was its lightweight design philosophy. Unlike the big, heavy F-15, the Fighting Falcon was all about being lightweight and affordable, but still able to outmaneuver bulkier opponents. Its single Pratt & Whitney or General Electric engine gave it a thrust-to-weight ratio over 1:1, so it could accelerate and climb faster than a lot of larger aircraft. The F-16's combat record covers conflicts all over the globe, from the Middle East to the Balkans. Israeli F-16S famously destroyed Iraq's Osirak nuclear reactor in 1981, showing off its precision strike ability, and during the Gulf War, F-16S flew more sorties than any other coalition aircraft, proving just how reliable and effective they really are. Continuous upgrades have kept the F-16 in the fight for 4 decades now. Modern versions feature ASO radars, advanced electronic warfare systems, and precision-guided weapons. The basic design is still so solid that new F-16S are still being built today, with the latest Block 70 and 72 models representing the very best in single-engine fighter tech.
FA-18EF Super Hornet, the carrier evolution.
The F/A-18E/F Super Hornet, known as the Carrier Evolution, is where Boeing took the proven Hornet design and turned it into something completely new. The Super Hornet is actually 25% larger than its predecessor, even though it shares the same designation. This leap forward gave us a fighter that combines the original Hornet's reliability with capabilities that can actually rival dedicated air superiority fighters. The Super Hornet was developed to address the original FA-18's limitations, all while keeping its proven strengths. The bigger airframe holds more fuel, which means it has the range needed for deep strike missions. Its more powerful F-414 engines deliver 22,000 pounds of thrust each, giving it supersonic performance even with heavy weapons loads. What really sets the Super Hornet apart is its electronic warfare version, the EA-18G Growler. It uses the same airframe but brings specialized jamming capabilities to the table. This means carrier air wings can keep their electronic warfare edge without needing totally different aircraft types, making logistics and training a whole lot simpler. The Super Hornet has seen combat in Iraq, Afghanistan, and Syria, where its precision strike power and survivability have been absolutely essential. Its advanced APG-79 AESA radar and integrated defensive systems give pilots the situational awareness they need in today's high-threat environments. Plus, its ability to serve as an aerial refueling tanker adds another layer to its multi-role flexibility. Even though it's called an upgraded Hornet, the Super Hornet actually shares less than 10% of its parts with the original FA-18. This major redesign created a jet that really performs like a new generation fighter, while still keeping the traits that made the Hornet so successful. The Super Hornet continues serving as the U. These 10 legendary fighters, honestly, they represent the evolution of aerial warfare from the Cold War right up to the cutting edge of the modern era. Every one of these aircraft pushed the boundaries of what was possible, from the Phantom's raw power to the Raptor's stealth revolution. They've defended nations, won wars, and inspired generations of aerospace engineers to reach even higher. The future of fighter aviation is going to build on the solid foundations these warbirds established. So which of these sky legends impressed you the most? Go ahead and share your thoughts below, smash that like button, and subscribe to Future Facts for more incredible stories about aviation excellence. Until next time, keep reaching for the sky. 15 billion miles from Earth, NASA's ancient Voyager 1 spacecraft just detected something that shouldn't exist. 305 massive objects moving in perfect formation through the darkness of interstellar space. These aren't planets, asteroids, or comets. They're something else entirely, gliding through the void with deliberate precision that defies every law of physics we understand. The objects appeared to communicate with each other through rhythmic pulses, maintained impossible trajectories, and displayed behaviors that left NASA scientists questioning everything they thought they knew about the universe beyond our solar system.
The Lonely Pioneer's shocking discovery.
What if humanity's most distant explorer just stumbled upon proof that we're not alone in the universe? Voyager 1, launched in 1977 when Star Wars first hit theaters, has become something truly remarkable. The first human-made object to reach interstellar space, the region between stars where our sun's influence fades away. This car-sized spacecraft has traveled over 15 billion miles from Earth, so far that radio signals moving at light speed take 22 hours to reach it. When engineers send a command, they wait almost 2 full days for a response. The spacecraft carries instruments that seem ancient by today's standards: magnetometers, cosmic ray detectors, and plasma wave sensors designed with 1970s technology. What makes Voyager's survival incredible is that it wasn't built to last this long. Engineers expected it to function until maybe the early 2000s, yet here we are in 2025, and Voyager continues whispering back to us across the stars. Its nuclear power source, running on decaying plutonium, was supposed to have died decades ago. The spacecraft also carries the famous Golden Record, a time capsule of Earth sounds, music, and greetings meant as a message to any intelligence that might find it. Little did we know this cosmic hello might have already attracted attention much sooner than anyone expected.
The first anomalous signal.
In the endless stream of data flowing back from Voyager, something appeared that would change everything. A tiny flicker that seemed like nothing at first. Space is full of dust and radiation, and occasional weird readings are normal, so NASA's Jet Propulsion Laboratory initially dismissed it as background noise. Suzanne Susie Dodd, one of the mission specialists who first noticed the anomaly, described it as like shouting into a canyon for decades and finally something shouts back. The reading was faint, just a slight reflection of light picked up by Voyager's sensors that seemed too minor to investigate further. But then something changed. This wasn't just a particle floating randomly through space. The object moved in a way that caught everyone's attention. It curved, accelerated, and didn't tumble chaotically like debris would. Instead, it glided smoothly, as if under intelligent control. When Voyager's plasma sensors registered a shift that seemed deliberate and focused, the team realized this wasn't background noise. Jonathan D.A. Clark observed that the object's movement was unlike anything natural, describing it as the kind of deliberate motion one might expect from a drone rather than a rock, suggesting it had intention. That observation changed everything, because in the physics of space, things don't just move with purpose unless something is making them move that way.
Ruling out natural explanations.
When something unusual appears in space, scientists have a standard playbook. They systematically check all familiar possibilities. Is it a small moon, distant comet, or new asteroid? One by one, the team worked through these options, and one by one, each possibility fell away. This object wasn't a planet, far too small. Not a comet either. There was no tail, no ice trail, no heat signature. It didn't glow like a star, and gravitational lensing couldn't explain what they were seeing. Even space dust was ruled out because dust doesn't suddenly change direction mid-flight. Dr. Nicola Fox at the Jet Propulsion Laboratory ran simulation after simulation, trying to match the object's behavior to known models. What makes space objects usually predictable is physics. Everything moves according to known patterns and forces. But this object broke those rules. Its path bent in ways that didn't match any known orbital behavior, with no drift or decay expected from natural objects. The team was forced to admit something difficult. What they were seeing wasn't just unknown, it was unnatural. The movement patterns suggested intelligence, or at least design. The object seemed to be moving with purpose on a specific trajectory that couldn't be explained by gravity, solar wind, or any other forces that typically influence objects in space. It was as if something was guiding it, adjusting its course with precision.
Confirmation from Voyager 2.
Just as scientists were trying to make sense of what Voyager 1 had detected, something extraordinary happened that transformed this curious anomaly into something far more significant. Voyager 2, the twin spacecraft following a completely different path millions of miles away, detected something eerily similar. The same kind of magnetic fluctuation, the same kind of pulse, a matching signal signature that changed everything. This was the turning point in the investigation. Two different probes, two separate instruments picking up nearly identical phenomena ruled out the possibility of internal error. It wasn't a software glitch or sensor malfunction on Voyager 1. Whatever this was, it was real and happening in multiple directions of space. ESA analyst Mark Fontaine compared it to two lighthouses, both catching a flash of something passing between them. This cross-confirmation gave the anomaly weight and credibility. It wasn't noise. It wasn't Voyager acting up. It was a real, coordinated phenomenon happening in the space between stars. The team now had evidence that couldn't be dismissed. Something was moving through the region where both Voyagers were traveling. With this confirmation, NASA quietly triggered what's known as a Level 3 alert, a designation used only for phenomena that don't fit within our current scientific understanding. The event was real, the math was consistent, the movement appeared deliberate, and nobody knew what to make of it.
The formation of 305 objects.
When the team analyzed the full telemetry logs, what they discovered sent chills down their spines. This wasn't just one or two anomalies moving through space, there were 305 objects, all moving together in formation. Each one glided past Voyager 1 in what appeared to be a choreographed arc, smooth, precise, and coordinated. These weren't debris fragments scattered randomly. There was no heat signature, no tails, no signs of decay you'd expect from natural objects. Most striking of all, the reading showed rhythmic pulses echoing through the plasma waves, the kind of pattern you'd expect from something engineered, not formed by chance. The 305 objects weren't simply passing through randomly. They were moving together as a unit, maintaining relative positions to each other in a way that suggested organization and purpose. In space, groups of objects tend to spread out over time due to slight differences in velocity and gravitational influences. Yet these objects maintained their positions relative to each other with precision that seemed impossible without some form of control or guidance. Some scientists compared it to watching a flock of birds or school of fish, except these were in the vacuum of space where such coordinated movement shouldn't be possible without technology. What made this discovery particularly unsettling was the scale. 305 objects all moving with the same unnatural characteristics, all passing by Voyager at roughly the same time, suggested something far more significant was happening in interstellar space.
The language of rhythmic pulses.
As scientists examined the data more closely, something truly strange appeared in the signals. Patterns of repetition that weren't the kind you'd expect from stars or cosmic background radiation, but steady, measured sequences that suggested communication or control systems. The plasma wave pulses coming from these 305 objects had loops, sequences, and structures that hinted at something more complex than random cosmic noise. They didn't just pass by Voyager, they seemed to broadcast signals as if they were pinging, scanning, or talking to each other. Dr. Serena Patel from Caltech observed that the patterns felt less like nature and more like a language or a system. The idea was shocking, but increasingly difficult to ignore. These objects weren't moving in a chaotic swarm, but in an ordered, intentional formation similar to how programmed drones might operate. Some experts went further in their assessment. ESA's Eric Lousy suggested this could be some sort of probe network, though he was quickly asked to stop speculating publicly. Even typically, Grounded scientists like Neil deGrasse Tyson admitted there were patterns in that data that aren't random. To be absolutely certain they weren't seeing a glitch, the team activated one of Voyager's oldest subsystems, a backup telemetry channel that hadn't been used since the 1990s. The backup system confirmed everything the primary systems had detected: the signals, the paths, the formations, all identical readings sent through a completely different channel. The implications were staggering.
Impossible propulsion systems.
Voyager's readings didn't just capture the presence of the objects, they revealed how these mysterious entities moved through space, and this is where things got even stranger. There were no engine flares, no ion trails, no signs of any propulsion system we would recognize, yet Doppler shift measurements showed these objects accelerating rapidly, smoothly, and directionally. Some were moving faster than anything humans have ever launched. According to the data, some speeds even exceeded the calculated escape velocity of the entire Milky Way galaxy. These weren't objects drifting passively through space, they were powered somehow, moving with purpose and incredible speed. Dr. Eric J. Zernstein from Princeton noted that they're not floating through space, they're navigating it. But what worried him more was their path. These objects didn't come near Earth or show any interest in our solar system. They passed by at a calculated distance, as if deliberately avoiding us or simply had no reason to stop. The method of propulsion remained a complete mystery. Nothing in our current technology even comes close to explaining how these objects move. They appeared to be manipulating space itself, creating waves or ripples in the fabric of space-time that allowed them to glide forward without conventional thrust. Theoretical physicist Elena Reyes described it as, not flight as we understand it, but more like gliding on something we don't yet know how to measure, as if these objects were using the medium of space itself to move.
Earth detects the echoes.
While NASA focused on Voyager's raw data, something odd started happening back on Earth that would make this mystery even more compelling. Across various corners of the globe, amateur radio operators, some just hobbyists with backyard setups, began reporting strange activity. They were picking up weak, irregular pulses, a kind of rhythmic static that didn't match any known terrestrial source. At first, it seemed unrelated, just coincidence. After all, radio interference happens all the time. But then the reports were time-stamped and compared. They aligned almost perfectly with the same hours that Voyager had recorded its most intense plasma anomalies. These weren't professional observatories or part of any official deep space listening effort. Most of these setups were built from spare parts, tuned to catch meteor scatter, amateur satellites, or solar flare chatter. Yet somehow they were detecting faint echoes of what Voyager had picked up billions of miles away. The signals weren't strong, but they had pattern and regularity, like ripples reflecting off invisible walls in the ionosphere. This raised a troubling question. Was this bleed-through accidental, or was it purposeful? Was something out there testing Earth's listening capability, dropping breadcrumbs for us to follow? That uncertainty kicked off a quiet storm behind the scenes. NASA began encrypting parts of its deep space telemetry feeds, and intelligence agencies took notice, beginning discussions about electromagnetic security and whether these signals could be weaponized or intercepted.
The machine awakens.
Then, as if things weren't strange enough, Voyager itself started acting differently in ways that defied explanation. Its guidance system, called the AACS, Attitude and Articulation Control System, began misbehaving, not catastrophically like a crash. But it started routing data through old, long unused systems, almost like it was bypassing its own core software. At first, engineers thought it was a bug. After all, this is a 47-year-old spacecraft running on code older than most people analyzing it. But the deeper they looked, the weirder it got. Voyager wasn't failing. It was reconfiguring itself, reactivating memory segments that hadn't been touched in decades, rerouting its telemetry in ways that were never programmed. Then came the kicker. This behavior began right after one of the magnetic pulses from the passing objects. Could that burst have flipped a bit of memory? Could it have triggered some dormant function buried deep inside Voyager's ancient architecture? What engineers found was both promising and terrifying. The machine was stable, the instruments were fine, but the new behaviors weren't going away. Whatever was causing them, it wasn't internal decay or software corruption. Voyager had touched something, or something had touched Voyager, and the spacecraft was different now. To understand what was happening, engineers had to dig deep, literally opening dusty file cabinets at NASA's Jet Propulsion Lab. Most of Voyager's software was written in early assembly language, with some instructions existing only as notes in 1970s paper manuals.
Part of something bigger.
As scientists continued analyzing the strange signals pulsing through Voyager's instruments, a new and even more extraordinary idea began to take shape. Among the plasma wave readings, certain patterns stood out, pulses that didn't behave like natural energy bursts but looked structured, measured, and intentional. Then someone noticed something else. The waveforms resembled quantum oscillations used in modern quantum entanglement experiments. These are the same kinds of signals researchers use on Earth to transmit information between particles separated by distance. It was subtle but undeniable, opening the door to a possibility no one had considered before. What if Voyager wasn't just recording random events in deep space? What if it had become part of something bigger? Maybe the 305 objects weren't just flying by. Maybe they were transmitting, broadcasting data through the interstellar medium using methods we don't yet understand. By pure chance, or maybe by design, Voyager was in the right place at the right time, with the right kind of analog sensors to pick it up. The signals didn't behave like random noise. They repeated, they looped, they followed harmonic intervals that looked eerily close to what you'd expect from encoded information. Something deliberately packed with meaning. Voyager, being such an old machine, might actually be the perfect listener. Modern probes are too noisy, filled with high-frequency electronics constantly transmitting and receiving chatter. But Voyager is slow, quiet, and analog. It has no clutter, no broadband digital static. It is, in a sense, the perfect ear in a cosmic concert hall, and being far outside the solar system, it's free from Earth's electromagnetic interference, just out there in the dark, listening like a perfect cosmic microphone. The mystery of Voyager's impossible encounter with 305 coordinated objects challenges everything we thought we knew about the emptiness of space. Whether these entities represent advanced technology from an unknown civilization, or natural phenomena operating by rules we haven't discovered, one thing is certain: the universe is far stranger and more populated than we ever imagined. As Voyager continues its eternal journey through the cosmos, it carries with it the possibility that humanity has just received its first glimpse of intelligence beyond Earth. What do you think these mysterious objects really are? Share your thoughts below, hit that like button, and subscribe to Future Facts for more mind-bending space discoveries. Until next time, keep looking up. For over 5 decades, humanity believed NASA led the race to Mars. But, recently, declassified KGB documents reveal a shocking truth. Between 1960 and 1973, the Soviet Union actually launched 19 secret missions to Mars, most of them ending in catastrophic failures, all buried under layers of Cold War secrecy. While Americans celebrated their public victories, USSR engineers were fighting a shadow war in space, desperately trying to beat America to the Red Planet. Hidden behind those generic Cosmos designations, these missions were basically erased from history. Today, we uncover the shocking truth about Soviet Mars exploration that nearly conquered another world. The secret war begins. October 1960 marked humanity's very first attempt at interplanetary exploration, and it exploded in, spectacular fashion. Soviet engineers at Baikonur Cosmodrome watched helplessly as their modified R-7 ICBM carrying Mars 1960A veered wildly off course just seconds after liftoff. The self-destruct command was sent immediately, obliterating the spacecraft and any evidence of the mission. 4 days later they tried again with Mars 1960B. This time the rocket reached Earth orbit, but the upper stage failed to ignite, leaving the probe stranded. Within hours, it re-entered the atmosphere and burned up completely. Both missions were quickly reclassified as generic Cosmos satellites to hide their true purpose from the world. The American press dubbed these mysterious launches Marsnik, a combination of Mars and Sputnik, but Soviet officials never acknowledged their existence. This began a pattern of secrecy that would define their Mars program for over a decade, with failures systematically erased from public records while engineers worked frantically behind closed doors. The first success. November 1962 brought a breakthrough that honestly changed everything. Mars 1 became the first Soviet spacecraft to successfully escape Earth's gravitational pull and head toward the Red Planet. Launched on November 1st, this 894-kilogram probe represented a massive leap forward in Soviet space technology. Chief designer Sergei Korolev had personally overseen the mission, equipping Mars 1 with a magnetometer, radiation detectors, cosmic dust sensors, and instruments designed to detect water vapor in the Martian atmosphere. For 124 days, the probe coasted through deep space, transmitting 61 successful communications back to Earth. Soviet mission controllers watched with growing excitement as their spacecraft traveled 193 million kilometers toward Mars. Then, on March 21, 1963, with Mars finally coming into view, all contact was suddenly lost. The most likely cause was a gas leak in the attitude control system, causing the spacecraft's antenna to drift off alignment. Mars 1 had proven interplanetary flight was possible, establishing the Soviet Union as a legitimate competitor in the race to explore other worlds. But it would remain forever silent in the void.
The plasma engine experiment.
Late 1964 witnessed the launch of Zond 2, carrying revolutionary technology that, honestly, wouldn't become mainstream for decades. Soviet engineers had equipped this 950-kilogram spacecraft with 6 experimental plasma thrusters, cutting-edge propulsion systems using electrically charged gas instead of traditional chemical rockets. Mission director Georgy Babakin believed these ion drives could provide precise course corrections during the long journey to Mars. The probe also carried an infrared spectrometer specifically designed to detect potential vegetation on the Martian surface, a bold scientific gamble that really reflected Soviet optimism about finding life. For nearly 6 months, Zond 2 flew steadily toward its target, with the plasma engines performing flawlessly during initial tests. Ground controllers conducted several successful engine burns, proving the revolutionary propulsion system worked in the harsh environment of deep space. But as the spacecraft approached Mars in August 1965, telemetry signals began weakening dramatically. Ground control lost all contact just as Zond 2 flew past Mars at a distance of approximately 1,500 kilometers. The probe had missed its flyby target by mere hundreds of miles, another agonizing near success that demonstrated Soviet engineering capabilities while highlighting the brutal challenges of interplanetary navigation.
The mystery gap.
Between 1965 and 1969, something extraordinary happened. The Soviet Mars program went completely dark. There were no public launches, no mission announcements, no press coverage whatsoever. Western intelligence agencies, honestly, they noticed this suspicious silence and began questioning what the USSR was planning behind closed doors. Internal documents later revealed that Soviet engineers were working frantically on their most ambitious project yet, simultaneous orbiter-lander missions that, well, would make American efforts look primitive by comparison. Chief designer Sergei Korolev's death in January 1966 had thrown the program into chaos, but his successor, Vasily Mishin, pushed forward with even grander plans. Teams worked around the clock developing heavy-lift proton rockets, advanced communication systems, and sophisticated landing capsules capable of soft touchdown on the Martian surface. The 4-year silence wasn't abandonment. It was preparation for an assault on Mars unlike anything attempted before. Secret facilities across the Soviet Union manufactured hundreds of specialized components, from heat shields designed to withstand Martian atmospheric entry to miniaturized scientific instruments capable of surviving the journey. By 1969, they had built the largest, most advanced interplanetary spacecraft in human history, ready to claim the Red Planet for the Soviet Union.
The Great Explosions.
March 27, 1969 brought one of the most catastrophic failures in Soviet space history. Mars 1969A, a massive bus-sized spacecraft loaded with cutting-edge instruments, sat atop a 190-foot Proton-K rocket at Baikonur. The mission was designed to place a heavy orbiter around Mars while simultaneously landing a surface probe, an unprecedented dual achievement that would, honestly, humiliate NASA's smaller efforts. At T0, the 4 first-stage engines ignited with 2.4 million pounds of thrust, lifting the enormous payload skyward. Then, 51 seconds after liftoff, disaster struck. The rocket exploded in a fireball so massive it shattered windows in villages 40 kilometers away. Flaming debris rained across the Kazakh steppes for miles, with wreckage scattered across an area larger than Manhattan. 5 days later, Soviet engineers tried again with Mars 1969B. This time, the first stage worked perfectly, but during stage separation, the upper stage failed catastrophically. the multi-million-dollar spacecraft tumbled back into Earth's atmosphere and disintegrated over the Pacific Ocean. 2 state-of-the-art Mars missions had been obliterated within a single week, representing months of preparation and millions of rubles lost in spectacular fashion.
First contact with Mars.
November 1971 marked the moment Soviet technology finally touched another world. Mars 2 and Mars 3 represented the USSR's most sophisticated interplanetary missions ever attempted, each carrying both an orbiter and a landing capsule. Mars 2 arrived first on November 27, with its lander screaming into the thin Martian atmosphere at over 20,000 kilometers per hour. But catastrophe struck when the parachute system failed to deploy properly. The descent module crashed, becoming the first human-made object to impact Mars, though not exactly as planned. 4 days later, Mars 3 approached for its landing attempt during one of the worst global dust storms ever recorded on Mars. The massive storm covered nearly the entire planet, creating atmospheric conditions that would challenge even modern spacecraft. Miraculously, everything worked perfectly. The parachutes deployed, the retro rockets fired, and the lander touched down softly in the Martian soil. For 90 seconds, Soviet Mission Control received clear signals from the red planet's surface, including the first attempted television transmission from Mars. Then, abruptly, the transmission died. Mars 3 had achieved the first successful soft landing on Mars, but survived less than 2 minutes in the hostile environment.
The Lost Rover.
Hidden inside Mars 3's landing capsule was a revolutionary piece of technology that, honestly, never got its chance to make history. Prop M, Pribor Otsenki Prokotomosti Mars, was the world's first interplanetary rover, a 4.5-kilogram robotic explorer designed to photograph the Martian surface and analyze soil composition. Built by Soviet engineers at Lavochkin, this lunchbox-sized robot moved on metal skis rather than wheels, connected to its mothership by a 15-meter tether that would transmit power and data. Prop M carried a dynamic penetrometer to test soil density and twin cameras for stereophotography. The rover was programmed to deploy automatically once Mars 3 confirmed a successful landing, waddling away from the lander like a mechanical insect exploring alien terrain. Its mission plan called for a systematic survey of the landing site, taking photographs and measurements that would guide future Soviet expeditions. But when the lander's systems failed after 90 seconds, Prop M never received its activation command. The tiny robot's computers never awakened, its cameras never opened, and its skis never touched Martian soil. For 50 years, this tiny Soviet robot has sat motionless inside Mars 3, buried somewhere in the Martian dust, humanity's first rover, forever waiting for a signal that will never come.
The cover-up campaign.
You know, the Soviet Union really perfected the art of making space failures disappear completely. Mission planners developed an elaborate system where any Mars probe that failed to leave Earth orbit would be immediately reclassified as a Cosmos satellite, a generic designation used for military payloads. This clever move allowed Soviet officials to claim they were simply testing Earth-orbiting technology, rather than attempting interplanetary exploration. It wasn't until decades later that Western analysts discovered the true nature of these missions through declassified documents and defector testimonies. For instance, Cosmos 21 was actually Mars 2 MV4A, a Mars flyby probe that never left orbit. Cosmos 419 was really Mars 8, a sophisticated orbiter-lander combination destroyed during launch. At least 6 additional Mars missions were hidden behind Cosmos designations, their true purposes buried in classified archives. Soviet engineers worked under tremendous pressure, knowing that failure meant not just technical setbacks but political humiliation that could end careers and send families to gulags. Success would be trumpeted worldwide as proof of communist superiority, but failure would be erased from history as if the missions never existed at all. This systematic deception created a false narrative that Soviet space exploration was more successful than reality.
The final attempts.
By 1973, the Soviet Mars program was bleeding money and credibility, but engineers pushed forward with 4 final missions that would either secure their place in history or end their Martian dreams forever. Mars 4, Mars 5, Mars 6, and Mars 7 represented the USSR's last coordinated assault on the Red Planet. Mars 4 was designed as an orbiter but suffered a computer malfunction and flew past Mars without entering orbit, becoming an accidental interplanetary probe. Mars 5 successfully orbited Mars and transmitted 60 images before radio failure ended the mission after just 9 days. Mars 6 achieved partial success, transmitting atmospheric data during descent before going silent just seconds before landing, tantalizingly close to becoming the second successful Mars lander. Mars 7 missed the planet entirely due to a mid-course correction failure, sailing helplessly past its target and into permanent solar orbit. The atmospheric data from Mars 6 proved invaluable, providing the first direct measurements of Martian air pressure and temperature during descent. After this series of near misses and partial successes, the Soviet Union quietly abandoned their Mars program. American Viking missions in 1976 would finally achieve what the Soviets had been desperately trying to accomplish for 16 years.
The legacy of secrets.
Today, declassified documents reveal that the Soviet Mars program was far more extensive and ambitious than the world ever knew. 19 separate missions were launched between 1960 and 1973, with only a handful achieving even partial success. Chief designer Sergei Korolev had envisioned Soviet cities on Mars by the 1980s, complete with mining operations and permanent colonies. Secret facilities across the USSR manufactured hundreds of spacecraft components, advanced life support systems, and even prototype spacesuits for Martian explorers. Internal reports from the 1960s show that Soviet leaders allocated massive resources to Mars exploration, viewing it as the ultimate propaganda victory over American capitalism. The program consumed enormous amounts of the Soviet space budget, with some estimates suggesting Mars missions received more funding than the lunar program during peak years. But technical limitations, political pressure, and budget constraints doomed most missions before they could prove their worth. The real tragedy wasn't just the engineering failures, it was the systematic erasure of these bold attempts from history. Thousands of Soviet scientists and engineers dedicated their careers to reaching Mars, only to have their efforts classified and forgotten for half a century. The Soviet Mars program remains one of history's greatest space secrets. 19 missions launched in complete secrecy, with most failures buried under Cold War classification. While NASA celebrated public victories, Soviet engineers were quietly achieving the first Mars impact, first soft landing, and first orbital insertion around the Red Planet. Their revolutionary technologies were decades ahead of their time. Though political secrecy erased their achievements from textbooks, these forgotten pioneers paved the way for every Mars mission that followed. Which Soviet Mars secret shocked you most? Drop your thoughts below. If you loved these hidden space mysteries, hit that like button, share with fellow space enthusiasts, and subscribe to Future Facts for more incredible declassified discoveries.